Alright, this section is about similar triangles and polygons, and like I mentioned in class last time, this will not be on the quiz, but everything that we did last week will be. Okay, so let's figure out what similar triangles are, and this applies to similar triangles or similar polygons. Doesn't really matter what the shape is. The definition is two triangles with corresponding angles congruent and corresponding sides proportional. Okay. So the angles are all going to match. They're the same, just like it was with congruent triangles. But now, instead of with congruent triangles, we had the sides being congruent. Now the sides are proportional, which means they have the same ratio. So we got the angles that match here, but that's not the same with the sides. So this is like putting it on the copy machine, but instead of making an exact replica this time, we shrink it or enlarge it. And the way we write the notation for that is we could say triangle ABC, and just like we write similar to, and then just like before we match up the angles, this would be DEF. And this symbol right here, this little squiggle, it looks like a tilde sign on the computer, means similar to. Alright, let's keep going. So in this, we want to list the congruent angles, write the statements of proportionality. Okay, we can do that. So they've given this picture to us, and we also have this similarity statement. And just like with congruent triangles, this similarity statement is super helpful. So if we want to list the pairs of congruent angles, we can do that because A is listed first. A is going to match with D, so we have angle A is congruent to angle D. And we have angle B is congruent to angle E. And last but not least, we'd have angle C is congruent to angle F. Now, the sides are a little bit different because they're not equal. Remember, they're proportional. So we're going to write them as ratios, but we're still going to match them up the same. AB is listed first, so AB is matched with DE. So I'm going to put AB over DE equals. Now I'm using an equal sign, so I'm not going to put a bar over AB or DE because I'm talking about the measures, and we're going to write it as a fraction. When I do this, though, it doesn't matter which triangle you start with on the top, but you got to stay consistent for all three of them. And then the next two would be BC corresponds to EF, and then last but not least would be AC matches with DF. Alright, perfect. Let's try this one. We want to know if the triangles are similar. If yes, we need to do a couple things. We're going to state the scale factor and write a similarity statement. So let's focus on first whether or not they are congruent. And I misspoke, whether they are similar. Well, first thing we need to do is check to see if their angles match. Well, we've got 2 of the 3 angles in each triangle. We've got to figure out the third to make sure it works. Okay, so if I do 180 minus 65 minus 42, I get 73 for this triangle. And over here, you can probably see it's the same, but we'll just double check. Minus 42 minus 73, I get 65 for here. And look at that. The angles work. Now we need to see if the sides are proportional. So let's go about doing that. Well, we don't really know what matches up because we weren't given a similarity statement, but we know the smallest side on one triangle is going to have to correspond to the smallest side on another triangle. So in GBR, the smallest side would be 12, and QST, the smallest side, would be 20. The medium side in GBR would be 15, and that matches with the medium side over here, which would be 25. And last, the largest matchups, that'd be 18 and 30. All right, now, written like that, that doesn't do us any good. So we need to reduce them and see if they're equivalent fractions. So we can divide both these by 4, and that gives us 3/5. We can do 15 divided by 25 both by 5, and that also gives us 3/5. And here we do these by 6, and that gives us 3/5. So all of them are the same. So because the angles were congruent, and all the sides are in the same ratio, then yes, they are similar. So we're going to say yes, they are similar. Okay. Now we need to write the scale factor. Well, the scale factor is whatever these ratios reduce to. This is your scale factor. So your scale factor is 3/5. And then last but not least, it wants a similarity statement. So it doesn't matter how we start the first one, the second one's got to match. So we say GBR is similar to triangle. Well, G is 65, so it's got to match with the other 65, which is S. B is 73, so that matches with T. So last would be Q. And there's our similarity statement. All right, let's try this again. This time, we've got to fill in the missing angles so we know whether or not they're similar. That's the first step, find the missing angles. Okay, so in the first triangle, I'm going to do 180 minus 96 minus 23, and I get 61. Okay, now right away, kind of see that we have a problem, right? Because the 96 matches, but there's no 61, and it's just not going to come out. We can try it, but okay, so 180 minus 96 minus 60 gives us 24. Yep, we got a problem. The angles do not match up, so since the angles, the corresponding angles are not congruent, we simply say it is not similar. And if they are not similar, we can't state a scale factor, we can't write a similarity statement. We're done. Alright, so we're going to find a bunch of things, answer a bunch of questions about the picture. Well, the first thing they want is the scale factor. So to find the scale factor, we have to match up two corresponding sides that both have measurements. Now let me show you one that doesn't work. If I do CT as 14, okay, CT is the first and last, CT would have to match with DG. Well, DG is blank. That doesn't help me. I can't match up 14 and blank. But CA and DO, they do match up. So I'm going to write 8 to 12. 12. And then I got to reduce that. My scale factor needs to reduce, and that's going to be divided both by 4 would be 2/3. That's my scale factor. All right, next question. They want the measure of angle O. Well, when triangles are congruent, their angles match exactly. So O is the same as A, and A is 73, so O must be 73 degrees. Now they want us to find OG. All right, so I'm going to start by writing the scale factor. OG is in the big triangle. Okay? It's right here. I'm going to call it X because we need to solve for something. So which side does OG match up with? Now I need to put X in the bottom because 2 represents a small triangle, and 3 represents the big triangle, and X is what I'm trying to find is in the big triangle. So which side corresponds with X in the small triangle? Well, that would be 6. So to solve this proportion, I get 2X equals 18, so I get X is 9. All right, now it wants us to find DG, so we're going to start with the scale factor. DG, we'll call it Y, so it's something different. It's in the big triangle, and I've got small over big, so big is going to go on the bottom. And DG matches with 14, so I'll put that there. So that leaves me with 2Y equals 42, so Y equals 21. All right, now it wants me to find the perimeter of DOG. Well, DOD is the bigger triangle, so to find the perimeter, that will be 12 plus 9 plus 21. Well, 21 and 9 is 30, plus another 12, that would be 42. Now it wants to find the ratio of the perimeters. Well, to find the ratio of the perimeters, I first need to find the perimeter of triangle CAT, right? I don't have that information, so I got to add that up. That would be 8 plus 6 plus 14. Well, 8 and 6 is 14, plus another 14 is 28, right? So I'm going to say the ratio of the perimeters is 28. Now ratios, we write the 2 dots in between, to 42. Okay, well we can reduce that. I can divide them both by 7, right? So 28 divided by 7 is 4. 42 divided by 7 is 6. Oh, that still reduces. That's 2 to 3. Well, that's interesting. That's the same numbers as the scale factor. Look at that. It will always be the same. Always. No matter what. The scale factor and the ratio of the perimeters will always match up because the scale factor is the same as the ratio of the sides, and the sides and the perimeter go together. Alright, let's try another one of these. Scale factor. I got to match up 2 corresponding sides. So I'm going to match up the 6 and the 4. Okay, so that's going to be 3 to 2. That part's easy. Okay, now what I haven't taught you about is parallelograms. And what you need to know is just a parallelogram is like a rectangle, opposite sides are congruent. So we would know then that this is 10, and this is 6, and this is 4. without even doing any work. We just know that. All right, but now it wants us to find EF. Okay, so we start with the scale factor. Oops, I wrote the wrong scale factor. Take 2. 3 to 2. And now we need to find EF. Well, if I look at my picture, EF is right here in the small parallelogram. Okay, and we've been putting the small on the bottom this time, so we'll put X there. And that matches up with 10. Alright, so I'm going to cross multiply, and I get 3x equals 20, so x equals 20 thirds. Now it wants to find the perimeter of EFG. Well, EFG is the smaller one, so I got to add up all the sides. Well, I know the top and bottom are both 4, and I know the left and right are both 20 thirds. Okay, so let's simplify that. That would be 8 plus 40 thirds. Now we need common denominators. So this would be 64 thirds for the perimeter. Okay, now they want the ratio of the perimeters. Well, we could compare the two, but no need to do any of that work. The ratio of the perimeters is the same as the scale factor. We just write it with the 2 dots in between instead of writing it as a fraction. And there's the ratio of the perimeters. And that's it. Okay, like I said, this is not on your quiz, but it will be on your test, and we will go over this in class next time.